Moving on to the back side of this worksheet. This is where it gets a little bit tricky. Okay, now it's not as simple as it was before. Now I have two exponential pieces. Each of those is isolated by itself, which is good. I need to have them in different places isolated, and they are. So now from here, I could do log base 4 of each side and get one of these things to cancel, or do log base 8 of each side to get one of these things to cancel. But instead, what I'm going to do is when you have two exponential pieces, I'm going to go right to using the natural log. Since that's what we're going to convert all this stuff to anyway, or the common log, but I'm just going to do the natural log of each side. So I'm going to take the natural log of each side. And remember, logarithms have special properties. So now I can take the exponent and I can bring it out front. So I can rewrite this as 2x natural log of 4. And then from here, I can bring this exponent out front. That's the x plus 4 times the natural log of 8. And now I'm just going to simplify a little bit. Over here, I'm going to distribute. So this is going to be 2x natural log of 4 equals x natural log of 8 plus 4 natural log of 8. And up from here, I'm going to use my properties of logarithms to simplify some of this stuff. For example, this guy, I can take this 2 and bring it back inside the logarithm as an exponent. I can do the same thing with this 4. Okay, that's my power rule for logarithms. So I can rewrite this as x natural log of 4 to the second, which is 16. And here I can rewrite this as a natural log of 8 to the 4th, which 8 to the 4th power is 4,096. And now from here, I've got to get my x values together. So I'm going to subtract the x natural log of 8 from each side. And what that leaves me with, I'm going to bring it up top over here. So I'm going to have x natural log of 16 minus x natural log of 8 equals the natural log of 4,096. Now to isolate the x, I have to factor it out. So I factor the x out, which leaves me with the natural log of 16 minus the natural log of 8. And from here, again, properties of logarithms is going to help me greatly here, because two logarithms being subtracted, I can rewrite as one logarithm of the two things being divided. So I can rewrite it as the natural log of 16 divided by 8, which is just a 2. And now we can see that this is going to be much easier to simplify and plug into our calculators. To solve for x, I have to divide by the natural log of 2. Over here, they cancel. I'm left with the x. Over here, this is just a job for my calculator. It's going to give me a 12. Okay? And the 12 tells me that I could have rewritten these as the same base and done it that way, using the method that we've previously learned. But this is good practice for solving using logarithms. Okay? For the next one, again, I'm going to start off right by going to the natural log of each side. So here, I'm going to rewrite it. Now I'm going to take the natural log of each side. Again, you can use common log. The process is exactly the same, except you're writing log instead of ln. And now I can bring that first exponent out front, the x minus 1, times the natural log of 2. Over here, I bring the x plus 4 out front, times the natural log of 5. And now it's time to distribute. I'm going to distribute this guy, and I'm going to distribute this guy. So that's going to be an x natural log of 2 minus the natural log of 2 equals, this is going to be an x natural log of 5 plus 4 natural log of 5. And now from here, I can do a couple different things. I'm going to start off by getting my x values to the same side by subtracting the x natural log of 5 from each side. So that's going to give me x natural log of 2 minus x natural log of 5. I still have this minus natural log of 2 over here equals, on this side, the only thing I'm going to have left is this guy. But I'm going to simplify even that guy a little bit by taking that 4 and writing it back inside the logarithm as an exponent. Okay, so 5 to the 4th power is going to be 625. So this becomes the natural log of 625. And now from here, I've got to get rid of this guy, so I have to add the natural log of 2 to each side. See, I'm isolating the stuff that has the variables in it. Again, I'm going to rewrite this up here. So I've got x natural log of 2 minus x natural log of 5 equals the natural log of 625 plus the natural log of 2. To isolate the x, I have to factor it out. So that gives me the natural log of 2 minus the natural log of 5. And I'm going to do this, this simplification using my properties of logarithms all in one step. Inside the parentheses, subtracting two logarithms is the same thing as one logarithm of the two things being divided. So 2 divided by 5 is going to be a 0.4. Over here, addition of two logarithms is the same thing as one logarithm of the two things being multiplied. So I can rewrite this as the natural log of 1,250. And now to solve for x, I just have to divide each side by the natural log of 0.4, or 0.4. So I find out that x equals negative 7.7824. And that's it. Okay, so again, the properties of logarithms are really going to save us a lot of work if we're good at using those. For this next one, again, right here, I can start off with the natural log, go right to doing the natural log. So I've got 3 to the 2x equals 6 to the x minus 5. I'm going to take the natural log of each side, which allows me to bring the exponent out front. So now I've got 2x natural log of 3. Over here, I've got the x minus 5 times the natural log of 6. On the second side, I have to distribute that natural log of 6, so I'm going to distribute. So here I've got a 2x natural log of 3 equals x natural log of 6 minus 5 natural log of 6. And I can use some properties of logarithms. I can bring this 2 back up here as an exponent. I can bring this 5 back up here as an exponent. So in my first one, I'm going to have x natural log of 3 to the second power, which is 9, equals x natural log of 6 minus the natural log of 6 to the 5th power, which is 7,776. Now I have to get the variable, the piece with the variables together. So I'm going to subtract this x natural log of 6 from each side. So that's going to give me x natural log of 9 minus x natural log of 6 equals a negative natural log of 7,776. And now from here, to isolate the variable, I'm going to factor it out. And now once again, I'm going to be left with 2 logarithms being subtracted. And I can rewrite 2 logarithms being subtracted as 1 logarithm of the two things being divided. And just be careful with this one. It's not going to divide well, 9 divided by 6. So I'm just going to leave it as a, well, actually, no, this one should divide okay. So if you just want to write it as a decimal, that's fine, 1.5. If you leave it as fraction as 3 halves, that's fine also. So negative natural log of 7,776. And now to finish solving this, divide each side by the natural log of 1.5. And now once again, it's a job for my calculator, so I'm going to plug it in. So it looks like that's going to give me a negative 22.0951. And that's it. All right. Again, these problems are a little bit involved, but they're much easier when you use those properties of logarithms. For the next one, or the last one rather, on the home stretch here. Again, I'm going to start off, I'm going to take the natural log of each side. So I do the natural log of each side. That allows me to bring the exponent out front. So that's going to be an x plus 1 times the natural log of 2 equals, this is going to be an x minus 4 times the natural log of 5. And now I can use my distributive property. So here I'm going to distribute, here I'm going to distribute. So that's going to be an x natural log of 2 plus the natural log of 2 equals, this is going to be an x natural log of 5 minus 4 natural log of 5. And the first thing I can do right away, again, is use my properties of logarithms to simplify this guy over here. I can bring this up as an exponent. So I'm going to, well, let's do 2 steps at once here. I'm going to subtract this x natural log of 5 from each side. Trying to get my variables together. So I'm going to have x natural log of 2 minus x natural log of 5. I still have the plus natural log of 2 over here. And over here I'm still left with this guy, which I'm going to rewrite as a negative natural log of, I can do 5 to the 4th power, which is the 625. And now I've got to isolate the variable more, so I have to subtract the natural log of 2 from each side. So when I do that here, I'm left with x natural log of 2 minus x natural log of 5 equals a negative natural log of 625 minus the natural log of 2. Now I can factor out my x to try to isolate it. And now from here, let's use some more properties of logarithms. Here, subtracting two logarithms is the same as dividing with one logarithm. So it's 2 divided by 5, which again is 8.4. And now from here, this is a little bit tricky. I can't necessarily rewrite this as one logarithm just yet because they're both negative logarithms, so it's a little bit confusing. The easiest thing to do here is to factor out the negative, which will leave me with the natural log of 625 plus the natural log of 2. So then what I'm going to do is rewrite that as one logarithm. That's going to be a negative. And now I can rewrite this as one logarithm of the two things being multiplied. I could have done this in terms of division, but it's a little bit strange because they're both negative logarithms. You have a negative and a negative, but I'm going to rewrite it this way. It's a little bit easier to look at, a little bit easier to think about. 0.4, and now to solve for x, I just have to divide each side by the natural log of 0.4. So I find out that x equals, again, I need to plug this into my calculator, so that's going to give me a positive 7.7824, which should look familiar. It's very similar to one of our other answers, except this one's a positive and the other one was a negative. All right. Hope that was helpful. And again, using those properties of logarithms should make these much simpler.